and welcome to the Land and Climate podcast. I'm Alasdair McEwen, and this week, the European Academies of Science, a grouping of the national science academies across the EU member states, has published a new report on the use of neonicotinoids and pesticide use. So I spoke to their Environment Programme Director, Professor Mike Norton, to go over their findings.
You don't really invent a benign pesticide, do you? They will say, go back and find something which is really nasty and toxic.
The report was released this week with the headline that the Academies supported the EU's previous decision to ban the use of neonicotinoids, but they were concerned that industry and EU member states were exploiting loopholes in EU legislation, which actually allowed the continued use of those pesticides. This comes at a time when there has been a flow of research documenting the speedy decline in the insect population and pollinators, with one study estimating that decline at around 2% a year. I started by asking Mike Norton to explain the new report and why it was being published now.
We're releasing this new report on neonicotinoids, or what we'll call neonics from now on, because this class of insecticides has proved a controversial issue at the European as well as global level for many years. We looked at it in 2015 when there was a lot of concern over initial reports of a lot of deaths of bees from use of these insecticides. And we conducted a very detailed study that showed to what extent these insecticides are very unselective in their effects on insects, and that there were much wider ecosystem effects than were being considered at the time. The Commission then banned the main three neonics, and those then were ruled unacceptable for using outside of any greenhouses. But despite that, a lot of what we call emergency authorisations or exemptions were continuously issued by member states, including the UK, to allow farmers to carry on using them for special crops and special pests. And in parallel with that, there's a lot of new products coming on the market to replace the ones that were banned, which basically had the same effect. So that raised the same questions as were there in the first place. And there was an increasing dissatisfaction with the success or lack of success in moving towards a more sustainable use of pesticides. And that led to quite a lot of resurgence in the policy debate in Europe on how to use this type of chemical and whether more restrictions were needed or how to change the testing system. So we decided 2 years ago to do an update and look at the current state of the science and try and feed into the current debate in the Parliament and the Commission.
And the conclusions of your report are what then now?
To put it into a real nutshell, we think the current Commission actions, which are to propose a tightening of the rules by upgrading a former directive called the Sustainable Use of Pesticides Directive into a regulation, that actually symbolises a tightening of the rules for the member states still in the EU. The 2009 directive was meant to shift this to becoming mainstream agriculture, but didn't make much progress in that direction. So the new regulation is trying to boost that original objective. So we spent a lot of time looking at the technology and science behind that approach, and also trying to address some of the obstacles that exist in the way of achieving that.
So, in a sense, your report is trying to give a push in terms of the way the Commission is dealing with the use of pesticides, but in particular, in this case, with neonicotinoids, or we'll call them neonics.
Yeah, I mean, that's how the report has ended, giving a bit of a push. But when we start these, we start with an open mind and we look at the evidence. The first focus of the report was really to update the science on the neonics themselves, because the European Union has prohibited these, but very few other regions or countries in the world have followed that. So we were wanting to update the science on that and say, well, were we too cautious, or what is the evidence 5 years on from when they were banned? And we actually found a particularly rich source in two regional studies we did. One we did in Africa, and one we did in Asia. And they really show quite a surprising picture of this class of chemicals really spreading around the world, which we knew about already. But now that there's some local research being done, the extent to which that's contaminated everything is quite surprising, actually, particularly in China, where they've done quite a lot of work and they use these a lot. They've got quite easy to detect in all the vegetable food stocks. It's in the drinking water, it's in the river systems, and you can even detect it inside inland seas, like the sea between two parts of Japan. The Seto Inland Sea has significant levels. And there's an Australian study which shows that it's even detectable at ecologically significant levels over the barrier reef, even though Australia is not what you normally sense as a huge country using these materials. And so all the evidence we brought up of all the sublethal effects, the fact that they have this cumulative effect, they sort of like eroding the brain, if you like, the insect brain, this widespread contamination into the environment really confirms the original decision by the Commission and agreed by member states to restrict those original ones. Now, of course, industry doesn't stand still. Industry wants to keep its business going. So there's always a fairly extensive R&D effort to try and find out new active substances, is what we call them. And what our report looked at was some of the long line of potential future candidates for replacing the original neonics, and basically saying, well, look, if you just tinker with the chemistry or basically design a molecule to achieve the same end results in the pest, then you could be quite likely to achieve the same negative side effects as the one you're replacing. And the one in sulfoxaflor proved that to be the case. There's another one which is currently going under scrutiny. And there's quite a lot of additional ones which are either in trial or actually in use in some parts of the world, but not yet Europe, where you may end up with the same cycle of coming through the approval system because the approval system doesn't adequately respond to that type of chemical, going through, putting it out in the field, and after 2 or 3 years having to ban it again. It makes you ask the question, are we a species which is capable of learning between repeating the same mistakes? But of course, in a legal framework, you may get entirely locked into that unhelpful cycle. The key thing is to reduce the use of these synthetic chemicals in the agricultural landscape overall. Look for this integrated pest management, which is a well-developed approach to agriculture, which has been honed since the 1950s, 1960s, where you use nature's power as much as you can. You use good cultivation, good management techniques, good tidying techniques to reduce the pest threat.
Yeah, and I was interested to read in your report that you even had a section which said that some studies found that the uses of neonics were neither effective nor cost-effective from the farmer's point of view.
The use we're talking about there is the widespread use of the neonic as a seed pre-treatment. So the farmer can only buy the seed with the stuff in there. And that's because the neonics were designed from the beginning to be a chemical which grows into the plant while it germinates and then grows, and makes the inside of the plant toxic to the pests that suck its sap or whatever. But it's very ineffective. Only about 5% or sometimes less of the chemical itself stays in the plant. The other 95% gets washed out and poisons or contaminates an aqueous system. And it's also there whether you need it or not, because if your aphids have been very poorly impacted by a cold weather or something, and there aren't really many around, you've still got the insecticide in the plant. You've still spent the money and you've still contaminated the environment to no particular reason. Those studies that are mentioned in there have looked at, comparing crops which have had the seed and crops which with the pre-treated seed and those which didn't, and found that in many seasons, many cases, the one without the pre-treatment did just as well because the crop pest wasn't at a significant level. So you've got this sort of totally unnecessary use. The only problem is you can't tell at the time you make the decision that it's unnecessary. So that again underlines the IPM principle, is that you only use the last resort of chemicals when you know it's needed.
Right. Because, the kind of underlying issue behind all this isn't it intensive agriculture or the intensification of agriculture.
It is, basically. And that has been very effective on a short-term and narrow basis. A farmer planting a very large field, particularly with sensitive crops like oilseed rape or sugar beet, wants just to get a one-stop shop solution. And if he or she can plant a treated seed and then forget about it for 3 months, then that's more attractive than having to employ people to keep an eye on the crop and measure pest densities and then make decisions based on that as to whether or how to have a counterattack on the pests. The farmer actually is more like a manager of a factory and sort of contracts as seeding and then contracts an intermediate spray based on a calendar rather than assessing whether it's necessary or not, then a contract harvesting and such. Once you've got into that sort of industrialized structure, it's quite difficult then to get some of that historical expertise or historical selectivity thinking back into the chain. The EU is trying to make that more selective and more discriminatory approach of the mainstream of European agriculture, and is not always getting the support it needs from the member states, who some of whom may be very much hooked on the conventional or industrialized agricultural approach.
And which member states are those? I mean, I imagine France, seeing as it has such a huge agricultural industry and agricultural lobby, that isn't friendly to change. Is that right?
Well, we haven't really looked into that degree of selectivity. We've been more looking at the scientific principles rather than looking at individual countries' breakdowns of agriculture. But you can get an idea of the pressures in that direction, because after the original neonics were banned, there was this emergency authorisation loophole in the European directive. And the conditions of those were meant to be fairly strict. And they were certainly meant to be emergency, but it all became a little more of a routine repeat authorization every year in some member states, particularly for flea beetle and sugar beet. So you can get an idea of the number of member states involved. And I think it was quite a significant proportion of the commission, of the community. Very important decision only last month was that a emergency authorization given by the Belgian government to use these banned materials on their crops was challenged in the European Court. And the European Court did judge. They were basically using it as a automatic rubber stamp for responding to requests from their farmers or some farmers to use the materials. And that was not in compliance with the directive, and that they should stop. So the court actually agreed with what some of the environmental groups had claimed, that this was being misused. It was no longer an emergency authorization. It was something that was become more like a rubber stamp in some countries. So the only one that is citable is Belgium, because that was the subject of the court case. But Hungary, Romania and others, I think Poland, and the UK has also done these emergency authorizations before we left the European Union. So I think it's fairly widespread.
Action on harmful pesticides has been quite slow. The first neonicotinoids were used, the report says, in 1991, and we're still using them now. Why do you think that is?
Going to a more fragmented and more decision-based approach is always going to have greater costs and greater time or expertise demands. And of course, that in a cost-based or cost minimization-based competitive market is not always welcome. So that's why we've listed a whole lot of different approaches where the Commission will need to help farmers and stimulate them and maybe pressure them and reward them for taking these more incremental approaches. That sort of approach is still being debated in the Parliament and in the Commission at the moment, which is why we try to bring out our report as soon as possible. There's a meeting, I think, this week in the European Parliament to discuss some of the measures that are involved here.
There's a bit in the report which says, ESAC shares concerns about the inadequacy of post-approval data on actual use and monitoring of residues in the environment. We urge the European Commission to continue to encourage member states to collect and disseminate such data. Can you explain that?
At the moment, a pesticide gets approved on a black and white basis as either approved or not approved. It's not then follow through with saying, well, how much did we actually use? There's really no post-approval monitoring until you get researchers saying, or beekeepers saying, it's just killed all my bees or whatever. You don't get any institutionalized follow-up. And the Commission actually, as I understand it, has been asking member states to at least provide data on how much of these pesticides is used in their particular state. Some member states, and I don't know which, have been resisting even that degree of data production. So that's our mild way of saying, well, don't give up yet. But the other side to that argument is just information on the quantities used is only the first step. We need to know more about how they were used, what crops they were used on, and any data which comes through on effectiveness or adverse effects. So that's why we also say that even though the first step is being resisted by some member states, there's a lot further to go. And we draw the analogy with medicines or pharmaceuticals, where after approval, there is like a reporting system and a monitoring system to look for adverse effects and side effects.
It sounds like we're not in a good way on pesticides generally. The EU is, relatively speaking, across the world, a leader in terms of regulation. But, even then, progress seems to be so painfully slow.
It's complicated by the fact that you don't really invent a benign pesticide, do you? I mean, if I am in a research laboratory and I come up with a lovely chemical which is not harmful to anything, they will say, go back and find something which is really nasty and toxic. I mean, that's the conundrum. I mean, you can only get an authorised pesticide if it is effective, so it has to be toxic. And then to say, we also want it to have zero effect on the environment or human health. I mean, that's a bit of a big challenge. And the whole thing is about managing the risk, not avoiding it altogether. The history is that we've tended to move too simply towards approval and then have to claw back later. And we started that with, back in Rachel Carson's time with Silent Spring. That was the wonders of DDT and all those, which were widely applauded when they were brought out, first of all. And then had to be clawed back because they got into everyone's bodies and affected reproduction systems and such. And each of these errors has led to an increasing review of the testing system. But there are some very special factors within neonics which still aren't recognized, and that is because they block a neural pathway in the brain, ideally the insect brain, but it's not recoverable. So that remains blocked. Even if it only blocks a proportion in one day, that proportion just goes up day by day by day. And most of the toxicity tests are based on short periods. So you get this huge difference between toxicity over like 2 weeks and toxicity over like 2 days, like a 100-fold difference. Yet the testing regime hasn't really adapted to that type of toxic aspect. And you've also got this huge water solubility, so incredibly damaging effects in water courses at very low concentrations, knock out all the insects in the agricultural landscape or the water courses, and you knock out the food for fish and birds and such. So you've got much more broader ecosystem impacts to consider with neonics than you would say with some short-lived, highly toxic material like the organophosphates and the others.
My thanks to Mike Norton for his time. If you'd like to read the European Academies of Science report, you can find a link to it on our website or on our podcast blurb, along with some further reading recommendations. Do also have a look at some of the new pieces we've published on the Land and Climate Review site, which you can find by Googling Land and Climate Review. And if you like listening to us, please do give us feedback and podcast reviews so that more people can listen to these podcasts. Thanks again for your time, and thanks for listening.